Histograms. The following frequency table shows the times in minutes spent by a group of women in a boutique. So the x-axis represents time in minutes and the y-axis represents the frequency. So that's the number of women, the frequency. Draw a histogram of the distribution. So a histogram looks very, very like a bar chart. The difference is the bars are all stuck together. And histograms are usually used for continuous data. So if we want to display numerical data involving time, weight, height, length, speed, distance, etc. So the time row of our frequency table goes from 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Notice that the second number in our first column is 10, and that happens to be the first number in our second column. And then the second number in our second column happens to be the first number in our third column, and so on. So it would be incorrect to have wrote from 0 to 10, and in the next one from 20 to 30, and so on, because if someone spent 11 minutes or 12 minutes, then there wouldn't be anywhere for them to go. So the second row shows the number of women. So for example, one woman spent between 0 and 10 minutes. We don't know exactly how long she spent, but it was somewhere between 0 and 10 minutes. 4 women spent between 10 and 20 minutes. Again, we don't know exactly how long they spent, but it was no less than 10 and no greater than 20 minutes. 8 women spent between 20 and 30 minutes in the boutique. 7 women spent between 30 and 40 minutes in the boutique, and 9 women spent between 40 and 50 minutes in the boutique. So when we're drawing out this histogram, we start off by looking at our first row, which in this case is time, and we see that we're starting at 0 and we're going up as far as 50. So we're going to start at 0 on our x-axis and we're going to go up as far as 50. And we see that our time row has intervals of 10. So 0 to 10 is a difference of 10, 10 to 20 is a difference of 10, 20 to 30 is a difference of 10, and so on. So we have to go up in tens on our x-axis. So 0, 10, 20, 30, 40, 50. So we're going to label our x-axis as time in minutes, and our y-axis can be labelled as frequency. It's usually labelled as frequency, or in this case it could be number of women. And then we're going to start to draw out our histogram. So it's very, very important that our bars are all stuck together. There can be no gaps. So in our first interval from 0 to 10, we're going up as far as 1. In our second interval from 10 to 20, we're going up as far as 4. And our third interval from 20 to 30, we're going up as far as 8. And our fourth interval from 30 to 40, we're going up as far as 7. And our fifth interval between 40 and 50, we're going up as far as 9. So since 9 is our highest value on our number row, our y-axis or our frequency axis can go up as far as 9 or 10. So we've gone up in gaps of 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could have gone up in gaps of 2, 2, 4, 6, 8, 10. It would not be a good idea to go up in 5s here, as our graph would be too squashed. So if we were going up in 5s, it would be 5, 10, and that would be it. So we would have a really squashed graph. So depending on the numbers that you're given in your frequency table depends on the way you're going to draw your x and y axis. So our first interval from 0 to 10 goes up as far as 1. So from 0 to 10, we want to go up as far as 1. So this is 1 on our frequency axis. So we're going to draw a line across and a line down at 10. So from 0 to 10, we're going up as far as 1. So we go to 1, we draw a line across and a line down. Our next interval from 10 to 20 goes up as far as 4. So at 10, we want to draw a line up to meet 4 on the y-axis. So at 10, we draw a line straight up until we get to where we're level with 4 on the y-axis. And then we draw a line across and a line back down until we get to 20. Then in our interval from 20 to 30, we're going up as far as 8. So at 20, we draw a line straight up until we're level with 8 on our frequency axis. And then we draw a line across until we're level with 30, and we draw a line down. Then from 30 to 40, we're going up as far as 7. So at 30, we're going to draw a line straight up until we are level with 7 on our y-axis, or our frequency axis. And then we draw a line straight across until we're level with 40 on our x-axis, and we draw a line straight down. And then for 40 to 50, we're going up as far as 9. So at 40, we're going to draw a line straight up until we are lining up with 9 on our frequency axis. Then we draw a line across until we're lining up with 50 on our x-axis, or our time axis, and then we draw a line straight down. Very important to use a ruler to draw our bars. So here we have our histogram completed. Note, 10 to 20 means 10 or more, but less than 20, and so on. Here are the times in minutes taken by a group of 14 students to complete a maths problem. So the first person took 1 minute, the next person took 1.5 minutes, the next person took 2 minutes, the next person took 2.5 minutes, the next person took 3 minutes, and so on. While it may not be obvious from the list, many of the times are between 4 minutes and 6 minutes. Also, few people had very low times or very high times. A histogram shows this distribution very well. So if we were to draw this out as a histogram, we would see that the first bar represents the people who took from 0 to 2 minutes. So only a few people took between 0 and 2 minutes. The second bar is for anyone who spent longer than 2 minutes but less than 4 minutes. So quite a few people spent between 2 and 4 minutes. The next bar represents between 4 and 6 minutes. So most people took between 4 and 6 minutes to complete the question. Then between 6 and 8 minutes, quite a few people took between 6 and 8 minutes, and only a very few took between 8 and 10 minutes. So we can see that most people spent between 4 and 6 minutes complete. We call this distribution a symmetric distribution, because our histogram is quite symmetric, so you could actually draw in a mirror line right through the center of it. It has the same image on either side. Now, a symmetric distribution doesn't have to be perfectly symmetrical, but we would usually have the higher bars in the center and the lower bars on the left and the right. In a symmetric distribution, the left half of the histogram is roughly a mirror image of its right half, so it's only roughly. Here are the times in minutes taken by another group of 21 students to complete the same maths problem. So we've drawn out the data for these 21 students on this histogram down here. And it's very obvious that the most number of people took between 8 and 10 minutes to complete the maths problem, because that is the highest bar. And the least amount of people took between 0 and 2 minutes, because that's the lowest bar. In this distribution, many students took a relatively long time to complete the problem. Here is the histogram for this distribution, which trails off towards the lower numbers on the left. So you can see it trails off towards the lower numbers on the left. So it starts high at the right hand side and gradually gets lower as we move towards the left. We call this a negatively skewed distribution. It is also referred to as a skewed left distribution. So a negatively skewed distribution or a skewed left distribution has much lower bars on the left of the histogram, and they gradually get bigger as we move towards the right of the histogram. So the left bars on our histogram on the left-hand side are lower. The following are the times of another group of 25 students who also took the maths problem. In this distribution, many students solved the problem in a short time. Here is the histogram for this distribution, which trails off towards the higher numbers on the right. So as we can see from our graph, the bars on the left-hand side are quite high, and as we move towards the right, the bars get lower. We call this a positively skewed distribution. It is also referred to as a skewed right distribution. So a histogram that has high bars on the left-hand side and that the bars gradually get lower as we move towards the right is known as a positively skewed distribution or a skewed right distribution.